Subject is AC machines to single phase induction motor. Single phase induction motor. So objective is here cross field theory of single phase induction motor. Here how to rotate the rotor. Stator coil wound for 4 poles. Stator coil wound for 4 poles. So this is the stator coil wound for 4 poles. Here the currents are so flowing passing through this wire. The direction here at the starting, here they are entering the winding. So here entering the winding, this is treated as the south pole. In this winding the current is entering, so this is treated as south pole, and after this wounded winding the current is leaving, from this, so it is treated as north pole. It is treated as north pole. Here this is the north pole and this one is south pole. Here see in after that the wind is wounded in this way. So this winding, so the current is entered, so it is south pole. North pole, after immediately it is getting here the south pole, after that this wounded, and then the current is going outward in this way. This leaving current is here, so it is north pole. And then after that here see, after that here in this way, here current is in this direction here. So observe this one. So current is in this way here, in this direction, current is in this direction. So here in this direction, here see, observe this one. So very particularly observe this one. Here current is in this direction, and here in this winding current is in this way. So here the pole is here in this way, the current is entering in this way. Here the pole is north pole. Here the current is entering in this way, so here the pole is south pole. After that current leaving, here the current leaving is, so here from this to, so this is this is south pole, and here current is, so here in this direction it is south pole, and current is here, this is leaving in this direction, this is north pole. So here stator coil wound for 4 poles. These are the 4 poles. These are the 4: south pole, north pole, south pole. So that means north, south, here south, north, south, north. This is the 4 pole stator coil wound for 4 poles. Now next, here when single phase supply is given to single phase stator winding, Stator coil carries current during the first half cycle of AC through stator coil. The current direction is inward in the lower half of the conductors and outward in the upper above the conductors. Due to this current, the flux is developed. Direction of flux given by thumb rule. The direction of flux given by thumb rule. So here the flux is showing how resultant flux is showing. The stator, see observe this one. For 0 degrees, 15 degrees, 45, 60, 75, 90, 105, 120, 135, 150, 165, 180, 190, 210, 225, 240, 255, 270, 285, 300, 315, 330, 345, 360. So how the flux is rotating and how the resultant flux is in that. So fields due to stator conductor currents and the resultant stator field. That means resultant stator flux. Here the cross field theory, here the stator and the rotor. In the cross field theory, stator and rotor. Here the single phase is supply and this is stator and this one is rotor. Here see here this the forces, how these forces will be along they act, and it is action of a single phase motor at starting. It is action of single phase motor at starting. So here how these forces are acting, see here of this how these forces are acting. So cross field theory, the direction of flux is horizontal, thus north pole and south pole are established. Thus the net flux due to stator coil current is horizontal. So once again the direction of flux is horizontal, thus north pole and south pole are established. Thus the net flux due to stator coil current is horizontal. So here the rotor flux, rotor receives power from the stator by transformer action. What is the transformer action? By mutual induction. Now the direction of current in rotor conductors is inward in the upper half and upward in the lower half. These currents also establishes, this current also establishes poles on rotor. So flux direction given by thumb rule. Flux direction given by thumb rule. It is also horizontal. Now see here the cross field theory figure is given. Here AC supply and here the cross and dot notations are given. The stator and rotor, how the forces acting on the rotor, here see here the forces how they are acting, here the F and here see the forces here, see and this force and this force how they are acting the rotors, fields, forces or fields. Now The fields of stator and rotor currents are aligned. The rotor conductors in the upper half of are pulled downwards and in the lower half of are pulled upwards. Here the rotor conductors in the upper half of are pulled downwards and in the lower half of are pulled upwards. So net force on the rotor is 0. See here, this one, this is a upper side, it is downward side, and here lower side it is upward side. This resultants will be give the 0. So rotor currents in the upper half are pulled downward side and the in the lower half are pulled upward side. So net force on the rotor is 0. So given an initial start to rotor, the rotor conductors cuts the stator flux. Rotor conductor cuts the stator flux. Then EMF is induced in the rotor, that is EMF generated in rotor due to generator action. So here the direction of EMF is given by Fleming's right hand rule, that is F or H. So here the current direction is outward to one side of the vertical axis and inward to the other side of the vertical axis. Once again, give an initial start to rotor. The rotor conductors cut the stator flux. EMF is generated in rotor due to generator action. The direction of EMF is given by Fleming's right hand rule. Current direction is outward to one side of the vertical axis and inward to the other side of the vertical axis. See here, action of a single phase motor. Action of single phase motor at running. At running case, this is the direction and this is a pi r, this is supply and the pi s stator flux. This is the rotor flux. Rotor has low resistance and high X. So rotor current lags the stator current by 90 degrees. So the field of rotor current is at right angles to the field of stator current. So rotor current lags the stator current by 90 degrees. The field of rotor current is at right angles to the field of stator current. Thus, the field of rotor is called cross field. Thus, the field of rotor is called cross field. So, due to this cross field, rotor rotates. Rotor rotates. This is the, here see cross field theory. Here this is the stator current and flux, the maximum which is given the waveform, sinusoidal waveform, it is drawn in the figure. So here this maximum sinusoidal, this is called stator current and flux. Next one is generated rotor EMF. Next one is generated rotor EMF. So EMF is when rotor cuts the flux, stator flux, EMF is generated in the rotor. So this is called rotor EMF, generated EMF. This one is rotor generated EMF. The stator current, stator flux, and rotor EMF both are in phase. Both are in phase. After that, from this, so here in the rotor is produces the current. That current is called the rotor current. From the rotor current, the flux is produced or established. Here, this is the rotor flux or current. It is lagging by 90 degrees. This is lagging by 90 degrees. This is the lagging by 90 degrees from 0 to, so this portion. This is the rotor current and flux. Now, see here, conclusion, when rotor is given an initial start by some external means, when rotor is given an initial start by some external means, then cross field is developed due to generator action. The cross field is developed due to generator action. See, observe this one once again. So read, when rotor is given an initial start by some external means, then cross field developed due to generator action. So here initial is start by some external means. So this cross field is developed due to generator action. So here the cross field is present only when the rotor is rotating. Cross field is present only when the rotor is rotating. Its field strength depends on the speed of the rotor. Its field strength depends on the speed of the rotor. Induction motor must run at a speed less than synchronous speed. Induction motor runs, it must be less than the synchronous speed. So cross field is somewhat weaker than stator field. Here cross field is somewhat weaker than the stator field. So conclusion, thus the rotating field produces the rotating field produced is not of constant magnitude, so but irregular. Thus the torque is pulsating. This pulsating torque produces noise and vibrations. So they are set on rubber or spring mounts to reduce noise which is inherent. So here once again, the rotating field produces is not of constant magnitude but irregular. Thus the torque is pulsating. This pulsating torque produces noise and vibrations. So they are set on rubber or spring mounts to reduce noise which is inherent. So at standard still, no cross field theory is present, only pulsating field is present. At standard still, no cross field is present, only pulsating field is present. So no rotation in rotor. So no rotation in rotor. Now next conclusion, if the rotor is rotated by some external means, it will continue to develop torque in the direction of rotation. If the rotor is rotated by some external means, it will continue to develop torque in the direction of rotation. The torque is pulsating The torque is pulsating. Summary: we have discussed about the cross field revolving theory. Thank you.